Welcome to SUSECon Digital 2023. This is the customer success story 1284 about Rancher Kubernetes and cloud-native container management for super large industrial machines. My name is Felix Efert. I'm Global Partner Manager for SUSE Rancher. This session is co-presented with my colleagues John Greatbatch, VP of Engineering at Container Solutions, and Ian Meyer, a partner at Container Solutions and the delivery lead for the customer I am talking about. Please note, this is a high-level cloud-native transformation use case. It provides an overview of the process, some helpful contextualization, and it mentions the technologies implemented. This talk is suitable for non-engineers and for decision makers. The content of this session is structured chronologically like the project itself. I'll start with the software delivery method that we found when the project started. Next big step was the migration from Mesos to Kubernetes, the breaking up of the monolith, and the RKE2 implementation. I'll finish with this brief conclusion. So let's get started and get to know the customer a little bit better. The automotive industry usually receives most of the attention as the hallmark of German mechanical and electrical engineering. An obvious reason is the passion and strong emotions that many drivers feel for their cars. But there is another area, less often in the spotlight, but equally excellent in engineering, historically and continuously. I am talking about the area of large and super large manufacturing machinery. Like every profession in business, manufacturing machines undergo a disruptive digital transformation process. Software engineering and platform engineering, they now converge with the traditional areas of mechanical and electrical engineering. Our customer produces very large manufacturing machines to produce industrial goods. Several thousands highly trained professionals assemble these machines on different sites across Europe. These machines are then exported globally. They are major pieces of hardware, with each machine costing several millions and generating billions of revenue and consistent growth year over year. The firm planned to refresh the software integrated with these large machines. The goal is to empower the end customers with a more agile, more effective software that provides condition monitoring and autonomous control capabilities. The benefit for the end customers is more reliable output and longer equipment lifetime on the shop floor. There is a very valuable benefits for end customers who invested millions into these machines in the first place. When this firm needed Kubernetes and container expertise, they turned to SUSE Rancher and Container Solutions. Let's see how the project started. Building such complex machines required teamwork, and this is a highly collaborative environment. The firm uses the Scaled Agile framework as its main methodology, with a 3-month cadence. Within that team, they have a product increment week where the teams huddle and commit to each other for the next 3 months. Crucially, the team's funding is also set on the 3-month cycle, meaning that if they need more resources in a particular area, they can spin up a new team or expand an existing one on short notice. Following good practices, each team consists of a Scrum Master and a Product Owner alongside the engineers. So in general, And perhaps surprisingly, given, say, somewhat poor reputation, this system worked well for our customer. The only weakness that Ian Mile observed was that there is less room for experimentation than it would be ideal. And this leads to late stage disruptive changes or significant delays when plans did not work as expected after the 3 months. We also found a generally healthy engineering practice. People speak up and they care about what they are doing. They have a strong engineering led culture with good alignment towards goals. So we quickly saw that container solutions could best help by bringing our cloud native experience to the customer's immediate delivery challenge. And in addition, we saw an opportunity to improve delivery more generally by reducing risk and increasing throughput by learning through doing rather than over carefully planning changes on a quarterly basis. Using cloud native software technologies require a learn or fail fast mindset, and that might be in contrast to the culture required to profitably ship multi-million euro hardware across the world. So we really had to strike a very fine balance there. On the technical side, Archie E2 and Rancher, they are most effective choices to accelerate application delivery. Transformational as these technologies are, we couldn't allow them to move fast and damage more than we could improve. So as a result, container solutions suggested a gradual path towards a more experimentational approach. And that needed to be strongly connected to the product engineering culture that worked so well for the customer. So, in other words, we wanted to move fast, but without breaking things. The first step was the migration from Mesos to Kubernetes. On the top of the physical hardware that the customer sells, there is a software platform called Virtual Compute Platform, VCP. This platform is developed in-house to host compute and analytics applications that aim to improve the yield in the customer's factories. These applications take data from production equipment and make real-time corrections based on it, which are then sent back to the production equipment. The original software platform, ECP1, was built in a monolithic style, with Mesos providing orchestration. Installations and upgrades were automated by Ansible. The platform also used several Apache projects, Spark for data processing, Kafka for notifications, and high-volume data ingestion, and Hadoop for storage. As part of a more comprehensive platform update, the customer engaged Container Solutions to review and assist with a planned migration from Mesos to Rancher Kubernetes. Although this sounds straightforward, the nature of the end customer's manufacturing process meant that it involved some unusual challenges. And frankly said, every customer is unique, and there's always some unusual challenges. So for one thing, in this case, the software has to be delivered through air-gapped environments via a terminal while being supervised. And then once the software is delivered, access to production is only allowed in exceptional circumstances, meaning you can't simply check production log files to ensure that everything is behaving as expected. Deployments also needed to be done without any downtime, and a failure of the platform has a high impact since it would cause a failure in the customer's production facilities. After the migration from Mesos to Kubernetes, we then moved to break up the monolith. Having helped the customer with the Mesos to Kubernetes migration, the Container Solutions then produced an informal cloud-native assessment to understand the current technology stack even better and design a transformation path towards the long-term cloud-native goals. Our general concern was that although the firm had done a great job building the platform, for VCP1 they had a tightly coupled, big ball of mud style build and integration architecture. Moreover, developers would work on individually handcrafted clusters for different periods of times. They could range from a week to a month or even years. And that created inconsistencies between the developer setups and the production systems. As a result, production delivery was preceded by a very, very lengthy integration and testing phase. The cloud-native assessment also helped identify the status quo in software delivery performance. So, for example, developers spent up to 50% of their time on bug fixing. Those insights together helped us to serve as a starting point for the systematic improvements. In addition, the firm was hitting the limits of its on-prem resources. Control of the build automation was under the control of a centralized IT team rather than the developers themselves. These constraints led to slower development through waiting for automation changes to be approved or machines to be deployed. To improve the situation, we recommended that the customer shifts left and moves to a pattern of continuous integration using cloud-native technology and processes. By breaking up this single monolithic build and delivery process into something more distributed, we ended up with a model Ian Meyer called the hierarchical producer-consumer model. It looks like this. In this model, the VCP2 team's components are built continuously off the main branch of all components. At the base level, VCP2 infrastructure teams build the core platform. Service teams then consume those infrastructure built components from their main branch. They build and test their components on top. The tenants at the top of the model are Java applications, which are essentially algorithms that run on the data held in a proprietary file format. The advantage of this approach is that it spreads responsibility across the different teams and introduces a feedback loop that allows them to scale their organization while reducing the chances of later integration errors. So we help the customer build VCP2 with this model, speeding up delivery time, reducing defects through the effort to shift left, and by improving continuous integration processes. On a technical level, the continuous integration pipeline On a technical level, the continuous integration pipeline is provided using Azure DevOps, with the customer's engineer building out their solutions with our guidance. This is how the VCP2 product is built. Let's take a look at the role of rancher. So from a technical point of view, RKE2, Ranch's next generation Kubernetes distribution, was the best option due to its focus on security and compliance with even the US federal government requirements, especially concerning the mentioned air gap data center use case. Rancher provided the comprehensive tools for managing containers, clusters, and applications along the development lifecycle, including the Azure cloud environments and on-premises use cases. Helm was used for the Kubernetes package management, Istio as the service mesh, and Splunk for observability. Conclusion. The new platform is called VCP2. The inconspicuous name for the new cloud-native platform highlights the unique quality of an area where engineering expertise and continuity have a very strong tradition. The introduction of containerized applications, the introduction of Rancher Kubernetes Engine and the Rancher Cloud Native Container Management across Azure and on-prem workloads moved fast, but without breaking things. VCP2 was successfully shipped to the first customer in February this year. I thank you very much for your attention. If this case caught your attention, or if you heard something that is similar to the challenges and issues that you currently work on, please don't hesitate to contact the Rancher team or contact Ian Meyer, John Greatbirch, or myself. I thank you for your attention and I wish you a most insightful SUSECon 2023.